Hi, I'm Brenden Fischer-Femal. I'm a PhD candidate at the University of Utah studying stable isotope geochemistry and climate change. I think we've come to a critical juncture in the journey of our species. On the one hand, we have groundbreaking technology that has made our lives easier, and we've discovered many things about the Earth and even ventured into space. On the other hand, we have massive wealth inequality. Many people live in poverty, and we are struggling to address the issue of climate change. One way to address climate change is to take the long-term view and look past short-term gains that might really hurt us later on. Geologists have a unique long-term view that can aid in this. One way that geologists look at the long-term view of things is by studying how carbon was released in the past and exactly what happens to the Earth in past carbon disruptions. So one of these disruptions I study is called the Paleocene-Eocene thermal maximum. It happened about 55 million years ago, about 10 million years after the dinosaurs went extinct. Now, during this event, carbon was initially released, but that release actually triggered other carbon reservoirs to also be released. This is projected to happen in present time as well. There's many old carbon reservoirs that have been either buried or frozen for long periods of time, such as permafrost in the Arctic and methane ice in the ocean. And when you warm it a bit, it can have a compounding effect because you release more and more CO2, which then warms the Earth more and more. This is called a runaway greenhouse effect. One way that we can slow down this runaway greenhouse is by carbon burial or carbon storage. And this is still a really expensive technique to create man-made carbon storage techniques, but it'll be integral in our fight against warming the Earth too quickly, which can create massive consequences for life on Earth. One mineral that you can put carbon into a stable reservoir is calcium carbonate. Calcium carbonate is a mineral that I specifically study. It combines calcium, carbon, and oxygen, and it forms naturally in a lot of systems on Earth, the ocean, soils, which I specifically study, and it's even in tums. The calcium carbonate that I study in soils can actually be used as a climate indicator for past climate change events. So I study the carbon isotopes in this carbonate over the warming event that I previously talked about. And this tells me how fast the carbon was released and what type of carbon might have been released and what reservoirs it was released from. So in this way, geologists can provide some insight into past warming events and perhaps future. My work is inherently interdisciplinary. I use physics to study the soil physics, diffusion gradients in the soil. I use biology to help me inform exactly how plants affect this process. And then I use chemistry to measure the isotope ratios and to help me discover exactly why the carbonate is precipitating in the soils to begin with. And all in all, geology is a keystone science in our future as a human race.